Then we come to the second talk of today. It's presented by Eric MacDonald from University of Texas in El Paso. And the talk is entitled Additive Manufacturing of Ceramic Multifunctional Structures.
Put this up here.
Eric, the floor is yours.
All right. Guten Morgen. That's the extent of my German. I'm an American, unfortunately. I do hablar en español, but the presentation will be in English. I think you might need to switch. Okay. So today I want to talk about something that sort of diverges from what I've heard at this conference for most of the 2 days, which is flexible, stretchable type electronics, and look at something that's rigid but still is printed and is potentially complex geometries and materials that are very high performance for electronics in terms of thermal management and even electromagnetic performance. Before I do, I'd like to just give you a little background on myself and my university. I'm from the University of Texas, El Paso. It's not the same as University of Texas, Austin, which is the flagship school. We're 1,000 kilometers to the west. We're closer to San Diego than we are to Houston, which is a testament to the size of the state of Texas. And I'm on the U.S.-Mexican border. My house and my office are both within 500 meters of Mexico. And I have recently gained about maybe 10 kilos because of the good Mexican food that's on the other side, and I probably cross twice a week. I'd like to do a couple shameless plugs. I am one of the co-founding editors of Additive Manufacturing, the Elsevier publication that started in 2014. During my tenure, it was the highest impact factor journal in additive manufacturing and in manufacturing, for that matter. But I've since gone on to become the editor-in-chief of a sibling, Additive Manufacturing Letters. And it's basically same content, but 5,000 words or less, not looking at references. Some of our best papers have come from Germany, and so I'm really here trying to solicit more papers for both journals. And if you have any questions, please let me know. And then another quick shameless plug. I write a lot of books or edit books, write chapters, but I was involved in a book this year with Amanda Schrand from the Air Force Research Labs in Florida that came out about resilient electronics for harsh environments. And a lot of what I'm going to talk about today would be in at least a couple chapters of this book. And then I should tell you that UTEP, the University of Texas El Paso, has had about a 2 decades long heritage in additive manufacturing. We were one of the first universities in the United States to get an RCAM, electron beams. It's a Swedish metal printer. But what I did was 3D printed electronics, where we would 3D print in polymers, interrupt the process, introduce electronics, and then continue to make complex 3-dimensional printed circuit boards. So the idea is to take 3D printing on the upper left, other manufacturing processes on the bottom left, to come up with this montage of things you see on the right, most of which has been done at UTEP. And I'll talk about some of them a little bit to give some context. But I can tell you that we, back in like 2007, we tried to 3D print a motor. My dream at this point was to press print 24 hours, open the door, and have a robot walk out or fly out. And unfortunately, in these days, these printers were basically ovens to reduce residual stress. So a battery sensitive to temperature couldn't be introduced. But here you're seeing a ball bearing, magnets being put in manually by a student. But in the end, we'll have a fully functional motor. The problem is we have to plug it in for it to operate, and you'll see that at the end. So this is a long time ago. This is like 15 years ago. And the point is this video is responsible for a lot of funding that we got at UTEP, and I'll let you see. So there he's putting wires into trenches. We've had a patented process where you could ultrasonically submerge the wires into the plastic. It serendipitously improved the mechanical performance, but gave you printed circuit board conductivity, right? Bulk copper. We used inks previously, and we still use inks. They have a lot of flexibility, but they tend to suffer from conductivity, and that's something I'm going to talk about in a moment. Here he plugs it in, and you get this fully functional motor. And again, this is responsible for some funding, millions of dollars of funding that we received in the next 10 years. So I ended up co-hosting a conference in Chile in Santiago, and I met this French guy